Greetings everybody, I am Jodh Kiran from S2ECA batch and I will be talking about, I'll presenting about microcontrollers and its evolution. So we'll be discussing about topics about the introduction, types and various things. So let us move to the contents. Today's agenda or today's contents or the presentation helps is the introduction of microcontrollers, the history of it, the types, advantages, disadvantages, applications, conclusion, reference. In between these things we will find some specifications of some microcontrollers and the difference between microcontrollers and microprocessors. So let's start again. So what is microcontroller? Its introduction. What is microcontroller? If we take the word microcontroller and divide, we will get a two-syllable word, which is micro and controller. If we talk about what is micro means something small. Controller, which means that controls everything. So if we combine these two words, we can get the whole essence of what this microcontroller is. Microcontroller is a small device which controls everything. It can be termed as a nano computer if we give synonyms to it, or it can be termed as a very small computer which it has everything. If we see a normal regular computer, it has CPU, in CPU it has mouse, in CPU it has input output ports, processor, memory, etc. All the things can be seen in a microcontroller, but in a very miniature form, in a very nano form. If you move to technical definition, microcontroller is a small computer which consists of single integrated circuits containing programmable processor, memory, and also input and output ports. The same thing as I said earlier, it is a small computer. It contains integrated circuits. So integrated circuits is the base of microcontroller or any microcontroller processor or microcontroller, whatever it may be. It consists of memory and also input and output ports. If we talk about microcontrollers, applications, one of the applications is it is designed for embedded application whereas microprocessor is used in personal computer consists of various discrete chips. What is embedded application? Embedded application is something which is already stored, data which is already stored in a microcontroller or in a device. It's called embedded application, which is already embedded in a device. The data already embedded in a device is called embedded application. Microcontrollers are a form of embedded applications, whereas microprocessors are two different. They are used in personal computers. You can see in motherboard, the computers, there are microprocessors as well. So if you move on to the history of microcontrollers, if you just as I said earlier, if you want to talk about microcontroller, you must know what is integrated chip is. So the first integrated chip was created in 1959 by Robert Noyce. The integrated was a monolith. It was a monolithic integrated circuit. So it was one of the first revolutions in the technological world in 1959, which was the first creation of first integrated circuit. Then in 1975, Intel company released the microcontroller, which was i8048. It was another a bigger version. It was another advanced version of an integrated circuit, which was i8048. The next in between, in 1980, 8051 microcontroller was introduced. It was one of the most popular microcontrollers, and it is still in use. It had very different specifications. It was very advanced in compared to that era of time where technology was very low. In that period of time, 8051 microcontrollers was like a god to the field of technology. Then in 1993, WPROM was introduced. WPROM is electrically erasable programmable read-only memory, which was introduced in 1993. It was one of those microcontrollers in which we can erase the programs which is already stored in it. So this is the small history of microcontrollers. Next we move on to the difference between microcontrollers and microprocessor. So these are the two terms which we get generally confused between, what is microcontroller, what is microprocessor. So microcontroller is a heart of embedded systems. Like I said earlier, the embedded systems are those systems in which the data is already stored in a device. Microcontroller is the heart of it. Microcontroller controls it. Whereas microprocessor is the heart of computer system. If we take a whole computer system, like if we take the central processing unit, the CPU of a computer, microprocessor is the heart of it. If there is no microprocessor in it, we cannot use the CPU. The same is with the microcontroller. If in a circuit, if we take a circuit in a data in an embedded system, if there is no microcontroller, there is nothing. So in a microcontroller, the next difference is memory and input are already present, making the circuit small. So if we take a microcontroller, the memory and the input output ports are already there in a microcontroller, whereas in a microprocessor, the memory and input output ports have to be given externally. So it makes it much more bigger. Even though the name is microprocessor, the as compared to microcontroller, microprocessor is a lot bigger because of the two, the two backdrops, which is the memory and external and internal input output ports are to begin externally, whereas in microcontroller it is already embedded in it. Since memory and input output ports are already present in a microcontroller, you can use it in compact systems because it's small, it's more efficient. So you can use it in compact systems. Whereas with microprocessor, since the size is getting bigger, it becomes less difficult. It becomes difficult to use, or more difficult to use in compact systems. The cost of the entire system in the microcontroller is very low, since of the above reasons, because it can be used in compact systems. The memory and the input ports are already present. Whereas if you take a microprocessor, in microprocessor there are very miniature chips. There are very miniature circuits which have to be created very with very concentration. So the cost systems go higher as compared to the microcontroller. In microcontroller, the total power consumption is very low as compared to the microprocessor, which is very high. The one of the major similarities between the microcontrollers and microprocessor is programs are very easy to write in both of these things. If you talk about the written programs of whatever the programs must be written in these things, it is very easy to write in both of these things. So next, the types of microcontrollers. So types of microcontrollers is it based on bus width, memory, its architecture, and various things. So if we talk about bus width, on the base of bus width, there are three types of microcontrollers. This 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller. If we talk about what is bus width means the number of bits transferred to the computer simultaneously. Bus width is the amount of the number of bits transferred to the computer systems simultaneously. So there's a 8-bit microcontroller, there's 16-bit microcontroller, 32-bit microcontroller. So 16 and 32 are the most commonly used because of their more efficiency. On the basis of memory, there is embedded memory, there's external memory microcontrollers. Generally, most of the microcontrollers have embedded memory systems. That's why it becomes more efficient, whereas very less number of microcontrollers have external memory, or the memories have to be connected externally. The next is on the basis of instruction set. There are two types, CISC, complex instruction set computers. The second is RISC, reduced instruction set computers. In complex CISC, the low level operations are being carried out, whereas in RISC, a set of high optimized instructions are carried out. So if we talk about the comparison between these two, RISC is very efficient and is more used generally than CISC. On the basis of architecture, there is a von Neumann architecture and Harvard based architecture of the microcontrollers. Architecture means how the controller is being made, on which basis, on which design it is being made. Both of these have different specifications, have their own differences, and they are being used on the basis of the demand of the systems as well as on the circumstances there. The next is on the basis of general use. There is a PIC microcontroller. PIC is peripheral interface controller. There is 8051, which is already discussed which we already told about in the late 90s and early 2000s. 8051 microcontroller. This AVR, advanced virtual controller. AVR, advanced virtual RISC microcontroller. There's ARM, Acon RISC machine microcontroller. There's an NSAS microcontroller. There is MSP, which is mixed signal processing. This mixed signal processing controllers. So these are the most commonly used microcontrollers: PIC, 8051, and ARM, because of their high efficiency with compared to the rest. Others are used as well, but in a very general terms, in very common terms. Whereas PIC, 8051, and ARM microcontrollers are used in more complex structures as well as used variedly. The next is specification of microcontrollers. In this, we are going to see the difference between the two technological eras. 8051 microcontroller was of late 90s and early 2000s, whereas STM32F20 is one of the latest microcontrollers present in the technological field. So we are going to we are going to see the differences, which is, if you can see, 8051 was 4K bytes ROM, whereas STM is 32-bit ROM. 8051 is 128 bytes, whereas STM is kilobits RAM. So we can, in these, by comparing these two, we can say that we can come to a conclusion that the technology has changed far. 8051 controller was used in the 90s with way less with way less in way less with way less you know specifications, whereas STM is one of those microcontrollers used variedly for complex structures. Like 8051 had just a serial port, whereas in STM you can find a USB port and SPI port as well. The data memory space is also very different. Like 8051 has 64K, whereas STM has 512 kilobyte memory space. So by comparing these two, by comparing the specifications of these two microcontrollers, we can come to a conclusion that the technology has changed very far. And step by step we are moving towards more faster, more accurate, more efficient microcontrollers. So the next is the advantage of microcontrollers. If we take the time, advantage of microcontrollers, the first is low time required for performing operations. Like in this microcontrollers, as I said, it's a small computer. So it's a small computer with much more efficient integrated circuits, so very less time is required for performing any operations. For it is easy to use, it's very easy to use. Maintenance is straightforward, troubleshooting system and maintenance is very straightforward. Processor chip is extremely small and adaptability occurs. In microcontroller the processor chip in microcontroller the processor chip is very very small, so it can be used in a large scale as well as in a much complex structures. The cost and size of the system is very very less. Cost and size is very very less, and these are straightforward to interface additional RAM, ROM, and ITIN ports. ITIN ports. These are very straightforward to interface additional RAM, ROM, and ITIN ports. The next is disadvantage of microcontrollers. It is generally used in disadvantage is generally used in micro equipment. So if you want to use it in large, in a very very big machines, microcontrollers are very difficult to use because they have very complex structures where they have very micro equipments. It has very complex structure. The number of execution is very very limited in microcontrollers. It is a number is as such microcontroller is generally in an embedded system, so the number of applications that are embedded in it can only be executed. Otherwise, externally there are way less number of applications which can be executed. Once microcontroller is programmed, it cannot be reprogrammed. So if we take a microcontroller, if once the microcontroller is programmed, that means once the applications are entered, it cannot be reprogrammed. So if one microcontroller is the work of the one microcontroller is finished, it has to be thrown away because it cannot be reprogrammed or can be reused. Microcontroller interface is a better powered device directly. Cannot interface a better powered device directly. If we can talk about that, uh, uh, microcontroller cannot interface a better power device directly. If we connect it to direct power, if we connect to microcontroller to a power device directly, it becomes very less efficient. Some applications of microcontrollers are consumer electronic products, instrumentation and process control, medical instruments, communication, office equipment, automobile industry. In these industries, we can see the varied range of use of microcontrollers. like in medical instruments, if we take the MRI scanning machine or the X-ray machine or whatever the machines may take, a microcontroller is present in it to make sure that everything goes very efficient, very smooth. In communication industry, in satellites, in telephones, in mobile phones, in whatever the communication this in the the setup boxes of the TVs, microcontroller is present. In automobile industry, to control all the sets. In robotic industry, we can find in every industry a piece of a microcontroller, or the just a vision of microcontroller can be found. So it's time for conclusion. We can say that microcontrollers have become essential component in last few decades. Since microcontrollers make the users work more easy, efficient and flexible, it will last till the end electronic device, which is not going to happen. So if we conclude by saying that microcontrollers is a very efficient technique. It's a very efficient device, which can be used as in a computer and various complex structures. So what microcontrollers has changed, was a transition or was a revolution to the technological industry, to technological field. And if we specifically talk about just about microcontrollers and leave the rest all aside, they have played a very bigger part in shaping very great industries, shaping the technological world that is of today. And the end of microcontrollers would be happening if there is end of electronic devices, since and that is not going to happen in the coming eras, because no one would discard any electronic devices. The mobile phones we are using, the laptops we are using, the computers we are using is all kind of electronic device, and all these things consist of microcontrollers. So we can conclude by saying that microcontrollers has is an essential component, and it cannot be degraded or it cannot be discarded just because of its nanotechs. And in the coming era, in the coming age, will grow to an extent, where in the places where we see, where we sit, where we sleep, a microcontroller could be found. So I rest my presentation here. Thank you all.